Cursor usually feels broken only after the wrong file wins the first read. In a big repo, several nearby candidates can all sound reasonable, and the session drifts before any patch lands. This video is about that exact moment, why it happens, why Cursor feels lost, and how to make the real path win earlier. Cursor usually feels magical in a tiny repo because the search space is forgiving. If there are only a handful of files that could possibly matter, even a vague prompt can still land close enough to the bug. That illusion breaks in a larger codebase. Similar helper names, sibling packages, generated clients, and old test fixtures all start competing for the first read. When people say Cursor got lost, what they usually mean is that the initial working set was too broad and too noisy. That is the frame for this video. I want to show why this happens and how to recover quickly. This is the failure pattern most engineers actually recognize. Cursor does not usually jump into nonsense. It jumps into something that looks plausible enough to keep the conversation moving. A retry helper in the shared package, a timeout module in a neighboring app, a test fixture that has the same names as the real, then the patch fails. But now you have already paid the cost of reading the wrong region. In a large repo, the expensive part is not only the bad edit, it is the wasted first pass. So the goal is to shrink the candidate set before Cursor starts trusting the wrong clues. This is the large repo problem in one frame. The prompt is vague. The index returns several locally reasonable candidates, and only one of them is the real bug path. The others are not garbage. They are just wrong enough to waste a cycle. In a small project, you often get away with that because the candidate explosion is limited. In a monorepo, one broad query can surface old fixtures, generic shared utilities, and sibling features that all look semantically close. Once Cursor starts reading those first, the rest of the loop gets slower. So the question becomes, how do you force the real path to win earlier? The most useful Cursor mental model is not that the agent understands the whole repo. It is that Cursor becomes precise after you feed it a better evidence stack. At files says read this first. At folders says stay in this neighborhood. At codebase retrieves nearby code after you have already trimmed the scope. Then the failing test keeps the conversation anchored to a real path instead of a plausible one. That ordering matters. If you ask codebase to search the whole monorepo before you pin anything, you are inviting drift. Precision comes from narrowing first and retrieval second. This is the practical recovery loop I would actually use. First, pin the file you suspect is closest to the bug, even if Cursor did not open it first. Second, cut the region down to one package or feature folder, so search stops rewarding lookalikes. Third, rerun the failing test, so the session has fresh evidence instead of stale assumptions. Only after that should you ask codebase for neighboring logic. That sequence usually recovers faster than arguing with Cursor in natural language. You're not trying to sound smarter than the model. You're editing the search space, so the right files win earlier. Large repo accuracy is not only about the prompt in front of you, it is also about the defaults you have already encoded. Short operational Cursor rules can say broad retrieval is not the first, move on bug fix tasks. A root agents file can define repo-wide habits, but it should stay global instead of trying to do every job. .cursorignore matters too, because retrieval should not waste effort on build output, generated clients, or stale fixtures. When those defaults are clean, the real bug path has less competition before the agent even starts guessing. This is the large repo Cursor loop I want people to remember. Start from the failing test, pin the file and folder, read the exact path, retrieve only the nearby code, patch the smallest surface, and then rerun the same verification. If the patch fails, you do not restart from a broad natural language prompt. You go back to the failing proof and tighten again. That loop is much more reliable in a big codebase than a generic ask like fix the checkout timeout bug. It keeps the session grounded in evidence instead of confidence. The point of a good large repo prompt is not literary elegance, it is boundary setting. Name the failing path. Name the allowed region, Give one verify command. Tell cursor what should stay off limits unless the evidence says otherwise. And ask for the smallest diff that makes the test pass. That shape works because it turns a vague bug report into an operational search posture. The prompt is no longer asking cursor to be brilliant. It is telling cursor how to spend its first minute. The one idea I would keep is simple. Cursor gets lost in large repos when too many plausible files can win the first read. Your job is to make the real path easier to win than the lookalikes. That means narrow first, retrieve second, and patch last. If you remember that order, the product starts to feel much less mystical and much more controllable. And that is the real large repo skill. Not asking for a smarter answer, but giving cursor a cleaner search space before it spends its first token.